So we have completed all the steps required for FEA. Now let's do post-processing phase. Let's find out first total deformation. We'll say insert a total deformation. We'll say evaluate all result. So deformation is 0.13066 mm and it's moving in this direction as expected. Let me see the undeformed wireframe also. So this initial position, this is final position, and this is around 3000 times scaled. So let's play animation. I will go to the graph option and we'll play the animation, right? So if we are pushing here and we are pulling here downward, so it has to obviously go like this manner as shown in the screen, and that is what our engineering judgment says. So its shape is correct. So that's for the first check, that it should deform like that. Second check is we have to see at the essential boundary condition, like fixed support and this displacement supports, it should match with the boundary condition we have provided. So let's see that. We'll go to total deformation. If you're not able to see this 3D part, just make sure you have thick beam, shell and beam and cross section option ticked in display. We'll go to the probe option and I will probe here. So it's 0 approximately, and here also it's a 0, right? So that is what it shows the deformation. Or let me use a probe option. I'll say probe, I will say deformation. I will select this node, we'll say apply. We'll say total deformation. We'll evaluate, so it's 0 mm at that location. Similarly, let me check out here. I will again go to the probe. We'll say deformation. We'll select this vertex. We'll say apply. And here I want to see the Y deformation because Y is a fixed, so it should be also 0. Right? So its value is shown here, 0 mm. Let me change from Y to Z. Z should be also 0 for that location. We'll say evaluate results, it's 0. We have allowed little in X. Let's see what we are getting in X direction for that probe. It's approximately 0 because there is not that much motion here. Now next is we want to do it. We have checked the sanity boundary condition is almost satisfied. Next, we would like to see the stresses. So for checking out stresses, I will go to the toolbox and will call beam tool. We'll insert a beam tool for all line bodies and we'll say evaluate results. Yes, we don't have a beam. We have changed from beam element to link 180 element. So we are not getting a beam result here. Right, so we cannot use the toolbox component, beam tool, and this beam results. It's applicable to beam 188 element, but we have here used link 180 element, right? So for that we have to do some user defined results. So I'll go to context menu solution and we'll go to user defined results. So for link 180 element, SMISC miscellaneous 1 is for the forces which we get. So I will write down here identify as a force, and let me right click and we'll say rename based on definition. So it's force for SMIS1, right? So SMIS1 will give us a force in this link 180 element. Next, I will just right click and we'll see duplicate this result and we'll write SMIS2, which will give us the area of this. So area is 10,000 mm square. You can check out that with our cross section here we have defined, right? So its area is 10,000 mm square. So SMIS2, just let me rename this based on definition. SMIS2 is giving us a area. Let me rename again. then I want to find out the stress, actual stress in this. I will again go to user defined result, and here I will type force per area. So it will be SMISC1 divided by SMISC2. You need not to type equal to here, it will be automatic. You just type the expression. Right, so let me put identifier as a stress and rename based on definition. We'll say evaluate results. So this is a stress in the component, actual stress in the component from this equations. So that's all in the post processing. If you want to see the reaction, you can just drag and drop this to here, so you can get the reaction at the both the ends, right? So here there is x direction minus 10,000 because here pull is plus 10,000, and y direction we have almost equals to 0 reaction here, and here is total 20,000, this and this 10,000, so it's 20,000 reaction coming here, right? So it's in equilibrium condition, applied force and reactions matches here. Now let's go for comparing this with our verification stages. So we have almost checked the sanity check, we have checked equilibrium. Changing the mesh will not alter the result that much. The last step is to check with the hand calculation, and that we are going to do next now.